All right, so in this video, I want to make another bridge like SDF model, but I want to do it a different way. I want to focus on having constraints that I set up at the beginning and then carry on through to the end. I want to also start using like a specific number to like as like an inspiration for all of it. And this one is going to be the golden ratio number. And what else? Yeah, and I want to start also working on the way that I move around on the screen where like I start using Control F and stuff like that and not using the mouse so much. So basically, I'm trying to improve the way that I write code. Even if I'm writing the same thing, I want to make it more enjoyable for me to write and hopefully more enjoyable for you to watch. So let's start. First thing I'm going to do is I'm going to define phi, which is going to be that golden ratio value there. And the code's not working right now because there's an error. So first opportunity to use Control F and go to map. Perfect. And so we have, I want to get rid of, yeah, this should be vector 3. Okay, so we got a box. We got a box and we also have, ooh, that's supposed to be my chromatic aberration happening, but it's somehow, like I don't like the way it looks, so we're gonna not do that. Oh, 1 second. Yes? All right, we're back. So, yeah, what I was saying was I am going to not use a chromatic aberration at all because it just didn't work that well. So I guess we're taking this out right now. Just keeping it simple, which means I should just use the regular, well, now this is the regular one. So yeah, texture, and then I channel 0, and then we're gonna use UV, and then that is a vector 4. So I guess we're good. Yeah. Okay, here we are at the start. So we have a box. Just make a basic this. And so what I'm talking about when I say I want to change the way I write things, let's go like right from the very beginning. So we got P, right? But I want to define, all right, so last time I was defining the variables as I went along. This time, one of the things I want to change is I want to define all the variables right now. So we have some P values that I want. So like PP, what else? Am I gonna have an ID as a vector 3 or a vector as a float? Okay, so that's gonna be a float. So we have PP. Let's just leave it PP. Okay, and then floats. We're gonna have a space float for the spacings between things that we repeat. An ID that will repeat. Can I do that? Yeah. What else? So PP ID, PP SP ID, then a new P. So we have all these now. So that's good. Put all that on one line. And so we're going to reuse the IDs over time, but we have them now. Is that all? So let's start with just making like a box. Let's make a bridge, but like I want to make the outline of the bridge instead of the bridge, because the outline is going to give us an idea of like the proportions, the dimensions that we can use like in future things. So we'll have vector 3, BD for bridge dimensions. And it's going to be vector 3, and we'll just be like phi. And then for 1, we'll be like floor phi. And then I don't know what the other dimension will be. Fract phi? That would be cool. Fract phi. So now we're only using that one number. And now we have our dimensions for the bridge. And then instead of putting a number here, we just use BD. BD. So this is going to be the shape of our bridge now. And because this is the shape of our bridge, And I mean, it could be like this or whatever, but like now we're gonna come down here and we're gonna make this whatever distance we need so we can see it clearly. So now we can see the bridge. So I want to try to keep it like keep the ray origin here the whole time, or else I should have like a few other camera angles and then not deviate from them. All right, so that's our bridge. Only using one number. The other thing is like I could even do this if I wanted to make it thinner, but I feel like it's a bit tall. Huh. The other thing we could do, because it's basically about what's gonna give us the best, like what's gonna look the best. What if this looks better as a bridge? So it's like wider. Or we could just do like we could just repeat it. Whoops. Like what if that was our bridge shape? I don't know. So whatever, we're gonna do this one, and then if we don't like it, the next time we'll do a different one. I mean, sorry, we're gonna do this one. Yeah, so we're gonna make a bridge that's gonna be shaped like this. That means it's gonna have like some long parts here, maybe some thinner parts as we move along, longer parts again. So after we made the bridge dimensions, we got to make a bunch of other dimensions. Well, okay, first of all, the other thing I was thinking was like, we can create a bunch of things just out of phi. So now one is phi. I know this is cheap. Like this is, I mean, not sorry, it's not cheap. It's expensive to do it this way. And actually that's one. This is going to be 618.6. I don't know how smart this is. 1. And then we go like 0.6. And here we go 1. So then yeah, so what other dimensions do we need? The dimension for, okay, so now that we have the dimension, oh yes, I get it. Now that we have that dimension, we need a dimension for the planks that are going to run the length of it. And then we're going to be like plank dim. And that's going to be like way smaller. So, and I guess the narrowest part of this is the 0.6. So we can use 0.6. And then we need like some other thing that's even smaller. Like, I don't know, 0.16, 0.16. What? Where is vector 2? Sorry. Vector 2 syntax error. Where? Here? I must be missing something. Yeah. No. So then, right, that's not gonna work at all. I don't know, this idea looked really good in my head, but now that I'm doing it, I'm like, how am I gonna make this, as small as it needs to be? All I can say is just make it really thin. Like, so we have, so if we're going along if this is the length, then yeah, this is Z, and then the new X and the new whatever has to be something else. So what I would want to do is create some really smaller versions of this that are also And you know what? More important than if I don't use any other number but phi is that everything is related to this dimension. So anything that happens here, like, because I can have like the number of planks, and then let's see. So now the number of planks can be whatever I want. N, and that's the number that has to fit in there, which means I have to take plank width is equaling to BDX divided by 12. That makes sense. That makes lots of sense. Whoops. I just wish I could use smaller. Alright. So now that's this. Well, sorry, it's N. Nice. And now we need the height. That should be even smaller. But let's also have it be related. Let's have it related to the plank width. So like plank height can be like plank width divided by, I don't know, 5. Is that cool? Like that. Yep. That's cool. So we got another piece. And this is where I would want to have a different angle for the camera, so I can see what's going on. Like that. So we have another piece. And that piece is going to fit the bridge dimensions perfectly. But is it going to fit? If I space things out, is it still going to fit? So the next thing I have to do is we have to space the plank out. The thing is, once we create all these variables, well, we should be able to use them again. Like, for instance, like plank width. Like, what if I did that but like, yeah, once we have enough of these, it's going to be fine. So 12. So now if I want to do a repeating version of this, then I take the ID, the spacing. So what should spacing be? Because spacing needs to be a certain amount that that's going to allow the actual number of planks to still be right in line with the dimensions of the overall bridge. And that's kind of complicated because we're going to have, well, if the spacing is 0, no. Okay, let's just work it out as we go. Start with 1, and then we're going to make an ID, which is going to be round, and then P, that's PP, sorry. Oh, right, let's declare PP. Because P, yeah. So round PP dot X divided by SP. And then we're going to have the new PP X. It's going to be SP times clamp. And then we're going to say ID. And then what should the size be? I want it to be like half of the bridge dimension X to half of the bridge dimension X, so that we get the full bridge. So BD X divided by, times 0.5, all the way, and that should be negative, all the way to the positive. And so we've added that. Right, and now we have to use PP for this. Uh-oh. And now we get a bunch of errors. So this is probably because of how much bigger. Oh. What is going on? When am I gonna see what I'm supposed to see here? Okay, that's very confusing. So I did SP. I don't know why there's such a huge artifact issue, but the ppx divided by SP, which is 1, is just basically round on the x. So we're splitting. Oh, right, because of how big wait, does Planck width have to be less than 1 for this to work? But it is less than 1. So that shouldn't be a problem. Huh. Anyway, times SP. No. What's going on? So no artifacts here. That's kind of weird. Right. Oh, yeah. Yeah. Round x divided by SP is ID. And then clamp the ID. And do this on either side to get the clamping value. Does it have to be a floor, maybe? No, doesn't look like the answer. We'll leave it like that for now, though. Is minus. Whoops. Okay. That's still kind of weird. But yeah, so we minus the IDs for everything up to clamp. We're getting crazy artifacts. This reminds me of something, though. It's very familiar. Pi is only 0.16, so if I use floor, then it's now 1. It's 1 to 1. Okay. So there's only 3, basically, which is already not enough. But still, what is this? Is that the answer? Yeah, that's probably what I did wrong. I was using 0.5. I was using some other thing. Yeah, that's what was going on. I was referring to some other to the article, the example in the article, but that's like those numbers are much larger than this. So it just ended up being weird. Okay. And now do I need floor? I guess so, right? But now we're completely losing the plot because we wanted all of this to be in relation to the box dimensions, and now we are clearly much larger than that. If I go BD, oh, okay, so that's the box size. So phi. So what is this then? Why is this so complicated? Why is this so phi actually looks like that? But then when we do this rounding thing and create a bunch of smaller versions of this box, and we even try to make it so that it goes from there to there, what we're ending up with is something less than the original dimension of the box, which is actually only like phi times 2. So what we really need to do is fit more of these planks within the same size of the box, but we need to make sure we're fitting inside the size of the box, and we're not. So why not? Well, I have, okay, so I have n plank width is 12, or is BDX divided by 12. So really, we need to be like this. This would be double if we did that. Yeah. So then we have to do this, but then now we have to go times 0.5 because n is 12. So then now we're going to have 6 on either side. Whoops. And that should work. So that should be the same size as the blocks. How can we tell? Oh, right. Oh, so now another thing I forgot to add. At the top, as a vector 2, are the t and the h. T is going to equal to vector 2, 100, big distance, and then 1. And then h is just going to equal, it doesn't have to equal anything yet. Then everything should be done with h. That's something I thought of last night before I went to bed. Everything will be done with h. And then we add h. So now, like, it's like much easier. Now we can make another one. And then we can use BD. So I wish there was a way to make this like semi-transparent. Like if this is 0, can you make it semi-transparent? That's a whole other thing, but that would really help me know what I'm looking at. But I think then you'd have to Raymarch through everything. I don't want to have to do that. Man, why does it look so messy in my situation? Hold on. This, that, and this. Yeah, okay. So, okay, let's just stop it somewhere like here. And then be like this. Put the mouse right here and see if the planks end there too. Alright. No. Ooh, that's weird. The planks are like over there. Why? I see. So let's rotate around the other side and see if that's like what's happening there. If I do, oh, whoops. Okay, one more rotation. And then there. Okay, what is going on? It is in line. Like it is exactly in line. Or close enough, right? I don't know why the box looks so much further away. It might be just that it's like the height. Yeah, it might be the height. Okay. So if I were to, oh, the other thing we could do is like, if I were to expand it, the plank dimensions, would we see it? Should poke through? When will it poke through? How long will it take to poke through? It's not poking through at all. Oh, that's the wrong direction. Okay. This is the 0.6. Yeah. 0.6. So if we go like this, we could see it, right? Look at that. So that tells us everything we need to know. That's how far these things actually go. And we can count them, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 probably. Oh, damn it. Yeah, I think there should be 13 because we have 6 and 6 plus the 1 in the middle. And it doesn't go the full length, which is interesting because okay, that's depth. No, wait. This is length right now. So that means and that's x. So that means we're talking the width, right? So if I increase this now, that fruit fly is getting, then we do that. So that's not exactly the problem. The SP, okay, if I made SP1, what would happen? Yes, now it goes, I'm guessing exactly, is that closer to, It's still not reaching the end. I wonder. Goes from negative to positive. Do I have to add one to either side? That would be a negative I. This fruit fly is killing me. Oh, that's increasing everything. Oh, because it's stretching the box. Ah, I get it. Okay, sorry. Yeah, so PP equals X. I mean, PP equals P. That's the original box size. And then we did all this crazy stuff. But the original box is actually here. So we actually need this all to fit in there. And it should fit once the spacing is such that everything is like touching each other. Like, right? 2.5. Wait, sorry. 2.5. Okay. 7, 8. So like 8 we're starting to see. Because 0.6 is... No, 0.6 is that. Never mind. So we need to... So what's going on? So the plank width... Is this divided by n? Because we have one more than we're supposed to. So it's actually like... We want this. And then we want to shift it so that it's right in line with the box. So we basically want to take P and move it on the X by half of a plank width before we do this stuff. Other way. What am I doing wrong? I'm trying to move it by plank. That's plank width. Yeah. By a whole plank width? It's changing the box. That can't be right. So there's plank width. Oh, it has to be before the ID also. So then all this has to be before the ID happens. Before anything that uses PP, you have to deal with the global. And then, okay, so now it's like this. So now it's definitely centered, I think. Why does that feel not the same? Yeah, it's the same. Okay. So that's centered. We did that. And then we did all of our ID stuff. And then we made the thing. And so it is around, it is going, I mean, it's basically the right dimensions for the bridge. It's just, it's not enclosed in the bridge the way I was hoping it would be. If that matters. Yeah. And there's also room to like change the number. That does that though. Oh, so there's like a specific number that's like, no, there isn't. Okay. All right, so we're creating the plank width based on dividing by the n. Why are we doing it that way? What time is it? It's been half an hour. Wow, this is a slower process than I thought. I guess because I'm thinking for myself today. Solving new problems. Let's save it. New bridge process. Okay, we'll move on and we'll come back to it. So we're gonna make another PvP, and this time we want to have like another shape that we can find based on. Hold on, maybe I can pull up a bridge. Pinterest bridge. Oh. Okay, so there's a bridge like that. That's actually closer to the other way of writing it. Um, that's definitely closer to like this. Can I just flip these around? Or would that screw things up? Let's see. Interesting. Anyways, this is gonna be a weird bridge. I do kind of want more planks. Oh, right, spacing. So this N. And what I want is to fit more of these inside this. Like I want to fit 20N inside this. So if I go to 20, it does that. Then I can bring down spacing to like this. I guess so. Something like that. But I want the spacing to be based on, like I want everything to be based on that one thing. So I want the spacing to be based on the um, like based on what the plank width is based on. So these don't depend on anything. So I can put them here. And then the plank width is this, plank height. So what if I'm like, I want this to be like 1/10 of the plank width. Oops. What's going on? Sorry. That goes directly to the size. Interesting. Is that no matter what, how many there are? Plank width. Yeah, because plank width is like divided by n, and then the spacing is like the plank width divided by 2. Then if I'm like times a little bit, whoops. Whoops. Goes straight there. And then point 1 is like this. Huh. Huh. And width, as we know, is actually like, I mean, sorry, the spacing is actually doing something different. That's like telling us how much space between each of these objects. But like the spacing isn't what that is. Like that's not like that number, it doesn't represent how much space there is between them. Otherwise, you know, it would be that. It's almost like it's the opposite. It's like the inverse of it. So unless we flip this, like I feel like if let's see, I feel like if we flip this, we can get something that makes more sense in that way. But then we would need to do like that. Just to say that. Now it's like, now is spacing the same as the width? No, I don't think so. because like the plank width is definitely not that large. All right, plank width. Okay, so spacing means that you multiply the world to increase or decrease it. You can leave spacing at 1 to get something more like general. And that's like when the spacing is 1. So now it's basically like you have 1 unit on either side, or you have 0.5 on either side of this thing. So these planks each are the width of, oh my god, 5 divided by 20. And now we do. So then round is saying for each of these blocks, we're going to just carve out that regular spacing around it. And that's what this looks like. So if I pause it, this is like a negative 0.5 to 0.5 interval here. And so if we were to use 2, then we would have like a negative 1 to 1 interval there. If we want to have something shorter, we have to use a number smaller than 1 to get a smaller interval. But what interval, like how can we relate the interval, the spacing to the plank width so that it makes sense? How are those two things related? Because like they're not. It's just we're just drawing something of that width. But we want to make, so like the spacing, we have to make the spacings like the way they need to be. Like we need to have spacings that like are kind of like the plank width and a little bit, regardless of like what the plank width is. And right now, 0.5 gives us a space of 0.5 around this. Okay, I get that. So 0.5 is a space of 0.5 around it. 1 is a space of 1 around it. So if plank width is this, and we want a space of plank width around it, then we do this. But that looks way too small. Like we're saying that's plank width, but it doesn't feel like it. Do you know what I mean? And if we do 2 of plank width, then we get that. So that makes sense. So like saying 1 gives us a space of 0.5 on either side. Saying plank width gives us a space of like half of plank width on either side of the plank. Which is just enough for the plank. But so how come times 2 gives us just enough space for times and then that? Right, so we can start to see, I think we're starting to see the cut. Okay, so that's right. Why does that feel so awkward to me? This fly, oh my god. But yeah, okay, so we're gonna do plank width and like a little bit. So that little bit is the actual ratio. Well, I guess this whole thing is the ratio. The spacing, you want the spacing to be such that you can see the lines, whatever. But then doesn't that mean that we should reduce the plank width so that we can see the spacing because we want everything to be inside the box. So that means this should be smaller than n so that everything fits in the box when spacing is the width of the thing. But that doesn't work. Less than 1? No. Yeah, that that's like, so that keeps everything inside the space of the blocks. That's right. And then this. So we added 1, and then we went 0.1. I don't know if that's like just a fluke, but adding 0.1 after gets us exactly to this, after adding 1 to here. I feel like that might just because n, so 20 plus 1. No, hold on. That can't be what's happening. Whoops. Like, that's not what's happening, right? Not exactly. Yeah, I know. Okay. I killed the fruit fly. Thank God. Okay, so we're gonna do, so if we add n plus 1, oh, n plus 2, then what if it's like 2, what if it's actually, um, what if it's like plus, no? Hmm. N, so 2 over n, which is 1 over 10, which is 0.1. Okay. What if we be like, no, I'm just guessing now. Huh. So if I go like 10, if I go 30, that's pretty stable. Look. Oh, the spacing gets smaller. Yeah, the spacing definitely. Ooh, and it breaks there. Well, it's an even number. Or sorry, odd number. Okay. Anyways, something like that. Still definitely more work to be done there. And then now what? Let's see. Where's the bridge again? So then we're gonna do some of those things, like stuff that's gonna go underneath and stuff that's gonna make the banisters. So let's start with we're gonna bring this down, or should we just bend it? This is where the artifacts can happen. I want to have like an arc, so I don't want to do anything crazy now. But I'm gonna make these things. So another PP. Actually, we should just repeat this whole thing. Boom. And then the box now will be another type of box. I wonder if I can just make it. Well, let's say, what are we gonna call those? Beam. And actually, I feel like it should be like this. Um, Flank dim. Vector 3. This. And this. And then we just use 0.6. Oh, we have point dim. Okay, I mean, yeah, okay. Whoops. What did I just do? I just put... Oh. Yeah, I can't do that because I'm making them all I'm making them all relative to each other. My mistake. So the beam dimensions, I want to use like the plank width for both of the X and the Z. And in between, I want to use the height of the VD. What? That's a vector 3. There's another fruit fly. The fruit flies are attracted to the lamp light, and then I guess my breath too. Beam dim. Ah, but we have to put them... They can't be just sitting in the middle. Although we can do this so that we can see them. Yeah, there they are. But there's just one. So now we gotta take this and we gotta go xz equals abs p, oh whoops, pp. xz, and we want to subtract half of the beam dim, or half of the bridge dims. Uh-oh. And I did that to px. Let's see. Why did that change the shape of other things? I put it in the wrong area. My bad. There. So that's if I added... What's going on here? There. Okay, cool. Ooh, that felt great. Okay. So it's the bridge dimensions. Exactly. It's starting to feel and look like something already. Easy stuff, man. And if I want to have an ID that's unique, then I just go ID and hash 11, and inside it go like pp, whoops, p x float to x less than, you know what, this should be, I should have a function for this. Now, if I have any function, it should be this, for sure. Rand abs, or r abs. That's going to take in a vector 3 called p, and it's going to return a vector 3 that's like float p that x is less than 0, float p, oops, p dot y is less than 0, and float p dot z is less than 0. And now we just pass it a p, and we're going to get back all the stuff we need. And we can use whatever we want. Abs p x z. We put both of those into the hash function. But that's two... That is two values. Okay, we'll add them. We'll add them. No, we should use a hash. We should have a 3D hash function. Let's see. But the thing is, I can't do all three, because then like we're gonna get different values for like the sec2 halves of the thing. So I need to create it. Our RA, and then RA x plus RA z, which is times some value, and make that our I. Shut it. Wrong operator. This one doesn't return a value. is that. Now it should. Whoops. Now down here. No mention overloaded function. I put P in. It takes what? P. What is P? Vector 3. Oh, it's not, am I not spelling it the same? Yeah. There. Okay. So there's that. Spelling of a function two times differently in two different places is like someone you're attracted to giving you their number, and then you just write the wrong number in your phone and then call it. All right, so I'm just trying to, okay, so that, just trying to illustrate what's happening here to people who aren't as experienced at this stuff. The H. So that's cool. So now I have a little function that I can just keep calling. That's going to give me all of what I need here. And I'm going to put that up here too. So now I have an RA. I can have happen all the time. So that's different IDs. And now what? Yeah, that makes things a lot easier. Glad I thought of that. And yeah, ID I, and then we want the next thing is to make some things like underneath the bridge. So we're gonna go basically this whole thing, and this is like a nice neat one, man. We have our PP, we got this, and it's just gonna be X now. And then we're gonna do that again, who cares? And this time it's just gonna be this. Wait, are we on X or Y? No, we're on Y, sorry. Alright, sorry, not Z, we're on Z. Z. So get rid of this. Just keep the Z. R. And then the dimension should be vector. I think we have enough things that we can now just start using things from what we have already. Like, I could use beam dim y as like the y component of this. No, sorry, x as a y component. But then I can use, for the x, it should be v dx. And then for the z, it should be like, honestly, Planck height. Planck dims y. I got it. Okay, but we gotta move it somewhere. So pp y plus equals, and we want it to go down. We want to lower it by the same thing. So that's how we can get it where it needs to be, I think. Uh-oh. Planck dim y? No, sorry, beam dim x. Whatever we use for the y value. I just use Z. Should I have a bit more than Z? So it comes out more. Now we can actually see it. Oops. Oops. I don't mind that. That's actually kind of cool. Yeah. like a lot of work for not a lot of result, but I know what I like. I can see that it's smoother. I just haven't done it enough yet to get the benefit of the smoothness, but it's way smoother. And now we need to have a thing going across. So a bunch of these things. Okay, so we're gonna make another repetition. Or we're gonna do two things. We're gonna make two more of these basically, but they'll be thinner. So instead of beam dim, we're gonna use plank dim again. So that we have that, but we're not gonna have it there. Maybe just half of it. Oh, does it have to come out more? Am I in the wrong? Oh, I'm putting this in the wrong place. Hold on. So that's another. Oh, I'm in the wrong place. Whoops. Bring this out. So that's another one. And then this should be half. What did I? What? Beam dim. Beam dim. Which one? Okay, no. BD. Y. Half of that. But then up though. There. And maybe like, we'll do this. We'll do one like that. And we'll do one that's higher up. So we got this one. And we'll have one more. And instead of having this. Yeah. So is there a way that I could do two of those? Yes. I could also do I could do that. Uh-oh. That's interesting. Because I do want to do an abs on both axes, but I don't think any of these dimensions are the right ones for the second thing. Oh, but wait, I guess part of it is this. So besides Y, we could use this, or we could use this, and those don't fit. So instead, oh, there's a few things I have to fix actually, because this isn't the type of bridge that has a lot of these. They have like the smaller ones. Okay, anyways, we'll come back to it. So we got that, and we want to make a smaller thing. So I'll just be like, I want it to make sense. So still BD Z times this, but then the second factor for the Y, it should be something smaller, but something that we know. So let's see. Right, okay. Like that. I was thinking this though. But there's three of them. So it actually fits a repetition better. Unless I want to have like a third abs, which I don't really like the idea of. Some sort of spacing. And then back spacing, ID, and it's just going to be -1 to 1. And that. That's 1. So spacing, but there's supposed to be 3. I guess there is, there's just one as I can't see it. So let's just go like that. There we go, that's all of them. And I'd rather have the spacing related to the actual whole thing too. Like what if I said it's like BDY times 0.3? Yeah. And then this too. Whoops. Where did it go? 0.66. That's like pretty cool. All right. So those are the railings. Now, oh yeah, and then for this, we want to have like the ID is going to be the ID. Plus the RZ, which is either positive or negative. So that's good. And ID. Cool. Another one. Let's get to the railings. Or the poles. So I want the poles to be the same size as the beam in terms of the Y. Beam, dim, Y. But then I don't want to use, let's see. I think I want to use like just like a slightly larger version of Planck dim Y. So let's just use Planck dim Y and see how it goes. And we're gonna make this on the X now. We don't need to do this. We're gonna make that BD, that SP is gonna be on the X, and we're gonna divide it by, let's see, so we'll make another number. How many of these do we want? Same as Planck's? No, like half as the amount as there were Planck's. And then we'll go N. So then we're gonna do the SP. Then we're gonna do that with that. And we're gonna go N to N. And again, we're gonna do this on Z, that makes sense. And it's gonna be Z and then ID. Whoops. Beam dim. Capital B is not there. Look at that. Beauty. That's the number of N that I want. But then the spacing is wrong. Right. So it's supposed to be like this. Yeah, there you go. That's the spacing. Although it goes in between the things. Is that what I want? And I want to pull them all out to the outside. And I think the amount that we want to pull them out is like I feel like I'm doing this like this is not the way I want to do it. But that's how I'm doing it right now. Okay, should the railings be on the outside or the inside? Like that. And those planks are gonna get narrower once I'm ready to do that thing. And oh yeah, these are too long. Like that's not the right, like we don't want that width to be the, or that length to be the length for Probably like half. Which means now we have to bring it all up. Bring it all up by half of the band, half of the same thing, like this. That's cool, right? And what else? I don't know, I feel like I'm ready to just remove that thing. I guess I could put like caps on the tops, like I often do. It's already been an hour. I just want to like, I need to eat. I need to exercise. So let's leave this here for now. Let's see. So I don't want this box here anymore. So let's take it out. No. Come on. This is the box I need to get rid of. There's our bridge. Okay. That's not bad. I mean, it's a very basic bridge. Oh, damn. You know what? One thing I want to do, I want to have something at the top. And I know how I'm going to do that. Wow, there's so much stuff here. Hold on. Vert gate. Torres gate. Okay, what would have had that? Vert, Torres, abs. What is this? Okay, let's get rid of it. That's these. Yeah, this is what I want. Okay. Bottom, long. Take this. And top long. And the top long is going to come around there. And the only thing, it's going to be like, not like that, but like that. Ooh, that's actually okay too. Okay, let's do one more. Top line, flat, flat. And we're going to take the same thing, but we're going to flip it. So instead of X being yeah, instead of that, right now Y is the tall part. We want that to be X. So this, uh-oh, no, okay, plank dim Y is the thin part. That's going to be the top. And then so that's top. That's Y. Take this and put it here. Okay. But no, right? Because it's supposed to be, I want that to be the long part. And I want this to be, oh man. Okay. But no. Now that's opposite. So everything is right except I need to flip these. I need to flip these like this. And then I have to bring it up more. That's what's going on. So that's BDY. So we gotta go like a bit higher than that then. Let's see. Like that. Like that. And also it's a bit out to the outside. I would rather it be in line that. Okay, maybe not. I don't know. I guess. Okay, there is our bridge. There's a ton of things that we can do. Hold on. I feel like these should be on the outside, not the inside. And that's making everything look weird. So beam. That's the beam. Okay. Right, so then Z should be like this. But like this. Yeah. Or this. Even that's pretty cool. Cool. Now, yeah, now it feels like you would walk on it. Like, feels like it's handling everything that you want to throw at it. And now back here, I would move this out a bit more. Like that. That makes sense. So now it's like, now that I did that, I just want to see where we're at in terms of like changing shapes. Oh, oh yeah. Well, it's not the exact, it doesn't totally work, but we've got some like opportunities here. 15, right? That's pretty good. And then instead of phi, what if I was using like pi? That's going to be a crazy change. 3.141592. What's the error? Fract. Like that. Phi. Okay. That's interesting. Wow, okay. Well, it goes on forever though, huh? So I guess it depends, like, and what if I'm like this? Okay, what if I'm like this? Isn't that weird? So there's like all these different bridges now. It's a bridge generator. And it's because of the way the fract works. Oh, that's so cool. So if fract is, so I could do that, or I could do that. Or I could do that. Whoa, and then the length. And then like, nothing. Interesting. Okay. Because that's kind of like changing. But the only thing I'm confused about is why this gate thing doesn't continue on as well. Why doesn't this continue on? So in the next one, I want to make it so like everything works and it makes more sense. But still, man, that's pretty cool. Lots of variety here. And now I want to take what we have here. Oh man, so I can just change this number. So I can get whatever width I want. That's cool, man. Just because I made it fract. Damn. The last thing I'll do, just to say I tried it, is like, I don't know, I'm thinking of making an arc, like making p dot y move based on the cos of x a little bit there. Just, yeah, and then that's it. It's already causing artifacts. Oh, right, color. Man, I keep leaving that to the end, huh? Bridge. And then colors. Oh man, I am getting tired of doing the color every time. Might want to add that to the template, but max dot, and then the SN. No, the SP or LP, and then the SN, which I didn't even define LP. gonna be like a light. It's gonna be normalized. I guess it's worth practicing that. And then it's gonna be like 1, 2, 3. So I got some that. And then on top of that, we're gonna go plus. Take this. I'm gonna go like that. And here it's gonna be like reflect this and that, and then RD. Reflect dot. I have an extra one. That's supposed to be out here. Or is it supposed to be 2? Okay. Okay, I think I'm seeing the light. Okay, so oh. Do I need to increase this? That's too much. Wow. Yeah, let's just leave it like that. Okay. Alright, I'm supposed to try to use God. Map. Supposed to try to do that. So I did it. And then there's like adding the noise on top if I really want to. I don't have to. Let's see. G noise equals F. Yeah. P. Yeah. And whoops, sorry. It's gonna get huge. Freaky. And also there's like 2 different. That one just goes away. So I might just go that row, but let's do this first. Ew. I mean, look at that. I mean, it looks like a chocolate bridge. Okay. So how about this? Yeah, I think that's more what we want. And just to add some thickness that we lose from the noise, gonna add it back like that. Man, these fruit flies are at it again. Stop it. Cool, that, and actually I'm just gonna get rid of the... I really like the coast wave, but it's just affecting things, you know? Like, it's causing so much of a problem. Oh, wait. Someone commented on another shader saying, like, I could get rid of the artifacts by reducing the step count. Or making it, yeah, so that's better. Okay, let's do that. Yeah. So now we've got this nice, interesting bridge. And I'm gonna add this. And I'm gonna publish it. Man. Uh-oh. Shader toy. Come on, shader toy. Come on. It won't even... Come on. Oh, I'm logged out too. Okay. Well, guess I'm logging in. I'm pausing this video. I'm pausing everything. I'm paused. Can I do that now? Okay, we're done. So that was my first attempt actually like talking through my thought process as I went about trying to make more interest, like I don't know, a more streamlined process of making bridge shaders. Bridge like, and it's like I'm not doing this so that I can make better bridge SDFs. I'm doing this so that I can make better shaders in general. It's just like I want this to be an exercise that it kind of like pushes me in the right direction towards having a more streamlined, fun process to write. And so that's what I did here. And at the end, we did get some interesting kind of like variations that were now accessible to us that weren't in the previous shaders, as far as I know, without more work. Um, so yeah, so I'm gonna make more of these. That's it.